Hello and welcome to Grade 9 Math. We're in Unit 4, Linear Relations. This is Lesson 5 of using mathematical models. By the end of this lesson, we'll be able to use a linear relationship in one form and determine its representation in another form. We'll be able to distinguish between numeric, graphical, and algebraic models of a linear relation. So I wonder, we'll take a quick moment here to recap how we could interpret these lines. So again, here we're looking at a graphical model and a algebraic model. So algebra basically means an equation, and graphical means a graph. So can you see one that is starting around what we could imagine being 5, and there's a downward negative slope. So I'm thinking, -5 or +5 is probably up here. -3 is pretty steep, like, going down 3 over 1, down 3 over 1. Yeah. So I would say this one, I think we can drag them. Yeah. Oh, you get back here. Okay, there we go. All right, let's keep looking. Now we know ones like this, there's no slope. So can you see one that's at y = 3? So y, 1, 2, 3. And it's horizontal because there's no slope. So we can move that one to here. All right, let's keep going. Now look at this one. They each have slopes. So maybe take the one with no y-intercept. So this one has no y-intercept. So we know that then it must go through 0. And there's only one other one that's going through 0 right here. So we bring that up. Okay, so then here's a couple tough ones. Well, not tough, I don't know. Look, they're both starting at -4. So both of these are starting around what we could imagine being -4. One has a really steep slope. So think 7 over 1. That's up 7 and only over 1. So that's pretty steep, right? Up 7 over 1. That's pretty steep. So then we can look at probably this one. Now, if we go really slow, like what's 0.2? That's like, that'd be -1 over 5. Right? So that's down 1 over 5. So that's like down a little 1 and over 5 quite a bit. So that would definitely be like this, down 1 over 5, up 7 over 1. So just being familiar with those kind of clues really helps. All right, great. So here we go. Recall linear relations are used to model situations that involve a constant rate of change, okay, our slope, and may or may not have an initial value. Each linear relation has a graphical model, as in a graph, an algebraic model, as in an equation, and a numeric model, as in a table of values. Given one representation of the linear relationship, graphical, algebraic, or numeric, we can create other representations using our knowledge of the initial value and the rate of change. So if we know our B and our M, we know our B and our M, we can usually go back and forth between the three types. Okay, so let's have a look at this first example. All right. The following graphical, so there we go, the graphical model shows us the relationship between cost in C and the distance driven in D in kilometers for a car rental company. All right, so given the graphical model, determine the algebraic model to represent it. So I want you to pause the video and I want you to try that out. Figure out your initial value and your slope. Okay, we're back. And here is the initial value. So we could say that b is 50. Now we need to figure out the slope. So look for very good points. 50 is a good point because it's right there on a grid line. Not so good point, not so good point, not so good point, not so good point, but nice point there. So let's go up 50 to 150. 50 to 150, well that's okay. That's 100. That's a difference of 100. Okay, now we're going this way from 0 to 500. So our rise is 100, our run is 500. So here we can say our slope is a rise of 100, and it should be positive, right? It is a positive slope, and a run of 100. So if you were to use your calculator, and we're talking about money, so money can be related to in decimals. So 0.2, so like 20 cents for every kilometer, right? So 20 cents per kilometer. So now, can we, that is 20 cents per kilometer, just so we keep that in mind, okay? And this is $50 to start. All right, to rent the car. So let's come up with an equation. They want us to use C and D. So the total cost equals two things, the initial fee and the rate. So the initial fee is 50 plus, well, we just figured out what M and X would be. So 0.2, and we're using D for distance. Very good. Or you can write it the other way around. C equals 0.2 D plus 50. Now, we're not done yet. We have our graphical model, we have our algebraic model, now we have a numerical model. Use either your graph or model or algebraic model to complete the table of values. So I would say we could agree that the graph is probably easier. So let's see if we can find 250. So 250 is right here, halfway between 200 and 300. We're going to go up and over to 100. Easy enough. Okay, you try the next one here. What about when our distance is 1,000? Ah, we don't have a graph that goes up to 1,000, but we do have an equation. So try your equation. So pause the video and give us a try. All right, we're back now. So let's take this all up again. So let's use our equation. We know our distance. So C equals 50 plus 0.2 D. And what are we going to put in for D? D is 1,000. 500, or sorry, 50 times D. Well, 0.2 times 1,000 will give us 200. So our total cost is 250. All right, let's give ourselves some room here. So 250 goes here. All right, next for C, we know the other way around. Now we know C. Okay, so C equals 50 plus 0.2 D. Right, let's continue. So C now goes in 300 equals 50 plus 0.2 D. All right, let's get rid of the 50. So we get 300 minus 50 equals 0.2 we're going to find out that this is 300 minus 50 is 250. 0.2d. Now we're going to divide both sides by 0.2. And what do we have here? So it goes in, that makes it a d, and it goes into it 1,250 times. Okay, so that's the distance he would travel to get up to. And it makes sense. Look, it's growing in length here and cost. So 1,250. Okay, so this all started from a graphical model, which we turned in a graphical model that we turned into an algebraic model, which in turn we changed into a numeric model. Very good. All right, example 2. The following numeric model, so a table, shows the linear relation between the cost of a gym membership and the number of exercises the class has taken. Determine an algebraic model to represent the relationship. So, an algebraic model would be an equation. All right, good. So, how are we going to determine whether it has, in here we can't really tell if it has an initial fee because we don't have a 0 here. So we might want to work our way backwards. And the other thing is, like, you start looking and go, well, I don't have a constant rate. This is going by 5. And this is going by 7. Well, those aren't constant. So we're having some trouble here. What was this? This is 1875. And what is 78.75 minus 52.50 is 26.25. So that's difficult, but we can still figure this out. Okay, so the rate of change is from any points. So if we want to find out the rate of change, okay, what is the rate of change? All right, we can find out that from one of these sections. So the rate of change would be our slope, right? Our slope is a rise. Now, if this is the x, this is the y. The rise is on top. So we have 5250 minus 3375 over 8 and 3 minus 3. And so what do we get? We get, well, we already did the math actually over here. So 1875 subtract 5. So what is 1875 subtract divide by 5 is 375. So that's our slope. Okay, that's how much it is for the number of exercise classes. The rate of the rate per class. All right, good. Now we know that, but we don't know what the initial value would be. So is there a way we could work backwards? Maybe. But we could also substitute. So if we had a skeleton equation, so something like the cost we could call, well, we used y up there, so y equals mx plus b. So the thing we don't know is b. That's what we want to know. Now, the thing we also know is we do know now our slope. So we can build on this and say y equals 3.75 times x plus b. And we don't know that what b is. So how we need to get rid of these variables. Do we see anywhere where there might be an x and a y? Again, this line or this equation relates directly to this table. So if you were to take, let's say, if you were to take a point, this is like a point, a coordinate of x and y, and you were to bring it down to here and substitute. All right, we're going to sub it in. So put me in, coach. Sub me in, coach. Okay, so for y, we're going to sub in 78.85. 78.75. Don't forget your decimal. Equals 3.75 bracket plus b. What was the x value? 15. Again, you could have picked smaller numbers, but okay, so we have 15. And look, now we have no other variables but b. We're trying to find out b, but now we have no more x's, no more y's. We can actually just deal with the numbers. So 78, 75 equals, well, what's that going to be? So 3.75 times 15 equals 56.25 plus b. Okay, so bring this over, and you're going to have 78.75 minus 56.25 equals b. 78.75 minus 56.25 equals 2250 is their initial fee. So let's go back to our skeleton equation then. Okay, therefore the equation would be, well, we had y equals, the m is the 3.75, that didn't change. And our x we leave as x. So y and x stay the variables because they change all the time. Plus, now that's where b is, 22.5. All right, so there we go. We took a numerical version of a table and turned it into a algebraic model in a equation. So looking forward, you have a series of questions. These are like matching questions. All right. And some more practice making equations and more problems and even more questions, changing it from numeric to algebraic to to graphical. But here you'll take graph 1 and work your way backwards. Very good. There's even a home activity you can try out. So I'd recommend this because I think it will help you on preparing for the quiz on this section. Okay, very good. And thanks for tuning in. And we'll see you next time.